Hello everybody. Today's video is going to be a little bit different because I don't have cookie cutter notes for this section. This section is just notes on line paper. So you should be able to find the key on the stream as well. I just wanted to make a video and kind of discuss a couple things that are kind of key in these set of notes. So our goal today is to find the length and midpoints of segments. So segments, we talked about that on day one, on unit one. And then the postulate, remember, this is kind of an obvious idea, something that doesn't have to be proven. And we actually have our one of our first postulates today. We learned a couple the other day, and here's another one. So this one is a ruler postulate. It's just that basically a number on a line is equal to, a number line is equal to the ruler. So basically, each number is spaced evenly apart. It's kind of like a ruler where each number has a location and a distance between them, okay? So we talked about what's the difference here between this AB, and this last AB. So this one here, you notice that it has the line over it, the arrows on both ends. So this is a line that continues forever in both directions, okay? This line above it doesn't have arrows on either end, so that is representing a segment, segment AB. A segment has two endpoints and an infinite number of points between them, okay? The one we didn't mention here are rays. Remember that a ray just has one endpoint and goes forever in one direction. But this one here is new, okay? We have not yet talked about what happens when you put A and B next to each other and you don't put anything over top of it, okay? That's actually representing the distance between A and B, okay, or the length of segment AB. So that's what that is. So if you're asked to find AB and there's nothing above it, what you're looking for is a number, a distance between the 2 points. And how we find that is by taking the absolute value of the location of A minus the location of B. The difference between the numbers will give you a number, and then you take the absolute value of that. Remember, once you simplify the inside, you just make it positive to find the absolute value. You should have done that back in Algebra 1. So over here we denoted what A is. A is the number location of point A, and little b is the number location of point B. So we're finding the difference of the locations, and then you just make it positive because distances cannot be negative. That's one of the reasons why some people like geometry, because we don't deal a lot with negative numbers and crazy numbers, because it just doesn't make sense in geometry. Geometry is a positive math. All right, so is segment AB congruent to segment CD? That's our question here. So is this segment the same as this segment? And in order for two segments to be congruent, that congruent word might be something new. It's the same as equals. It's just that in geometry, figures are going to be congruent. Numbers are equal, but figures, we call them congruent. It just means that they're the same, okay? And in order for, so over here we wrote the symbol, this means congruent, and we're going to see that symbol all the time. We use it all the time in geometry, so that's going to become second nature. If it looks really strange to you right now, no worries, it'll become second nature here eventually. So figures are congruent where numbers are equal. We wrote that all over here. And if segments are congruent, then they must have equal lengths. So if I have one segment that is a length of 3 and another segment that's a length of 3, then they're going to be congruent. If one of them's 3, the other's 2, then they're not congruent. So that's what we're trying to look at. This was a picture that was drawn here, and we have these points A, D, C, and B. They all have different locations. It's almost written on a number line, like or it is written on a number line. And if we were to take a ruler and measured from A to B, is it the same as if we were to measure from C to D? And we could do that because the number line has numbers. So I color coordinated it. A to B is the screen. So we know that that equation is going to be A minus B. Okay, the location of A minus the location of B. So the location of A is at -1. So we replace A with -1. Minus the location of B is at 6. Okay, so -6. -1 minus 6 is -7. Take the absolute value of -7, and it's 7. So AB is 7. CD is the location of C is 5, so we fill in 5 there. If you want to use parentheses, sometimes that helps too, so you don't forget that minus sign. Minus the location of D is -2, because some people will not put another negative here. It's minus -2. Well, what happens when you subtract a negative? You're adding. 5 plus 2 is 7. The absolute value of 7 is still 7. So AB and CD are both 7. Those numbers are equal. AB and CD are equal. And the segments then are congruent. Okay. If it helps you, sometimes people will make a picture like this one over here. If E is at 74 and F is at -5,000, find EF. You can use the formulas like we discussed. I often will do this route. And even sometimes I visualize this in my head and then I'll draw it out. So 0's on the number line. I have E is going to be to the left of the number line at -5,000. F is going to be to the right. Notice I did not draw this to scale. 5,000 is not almost the same distance away from 0 as 74. But it's okay, because what I did here was I showed this distance is 5,000, this distance is 74, and I know I'm just adding those together to get that EF distance is 5,074. So you can use a sketch or you can use the formulas, whichever you're more comfortable with. All right, so then also midpoint, to find the point that's in the middle of two locations, it's just going to be the average of the two locations. So if you're trying to find the middle of D and B here, between 1 and 6, if you just take the average of 1 and 6, so 1 plus 6 is 7, divide that by 2, because when you're finding the average, you add up everything, divide by the number of things you added together. So 6 plus 1 is 7, divided by, we added two numbers together, it's at 3.5 is your average. Okay. So a midpoint of a segment is a point that divides the segment into two congruent segments. That is another vocabulary term we have not yet defined, but a midpoint is just going to be the center of two segments. It's going to divide a segment into two congruent segments. So if B is the midpoint here, it's going to be exactly in the middle of A and C. And you'll notice it says B is the midpoint of A and C. We have these symbols here, and those symbols are what we call congruent marks, okay? So they have matching congruent marks, which means that the segments are congruent. It means that AB is marked congruent to segment BC, meaning they have the same length, which is why B is in the middle. Okay. If it tells you that something is a midpoint, you know that the parts are then going to be equal. You're going to have equal parts up there. All right. So here's an example of how we would solve a problem. I believe this picture is what is given. Okay. They gave us EF and then FG, but those marks were there, which made us know that they were congruent. They told us EF was this expression and FG was this expression. So they gave you these two equations, and we have to solve for X first. Okay? So I know that EF and FG, those segments are congruent. So since I know these are congruent, I know the lengths have to be congruent. So I'm setting part equal to part. Okay, those parts are the same, so I can set them equal to each other. This is using your basic algebra skills in order to solve for X, and we get that X is 5. All right, that's the first step. It's probably also going to ask for the lengths. So over here, not only did I find that X was 5, but if you plug 5 back in, 2 times 5 is 10. 10 plus 1 is 11. EF is going to be 11. FG, what should it be? It should also be 11, because remember, part was equal to part. So let's make sure. 3 times 5 is 15. 15 minus 4 is 11. So we also got that FG was 11. If it asks you for EG, then EG is going to be 22, because that's the whole length. Okay. The next postulate we're going to be talking about is the segment addition postulate, and that's just that part plus part equals whole. So if you add this part and this part together, it equals the whole thing. And actually, you use that up here if you figured out the whole thing was 22. If this part's 11 and that part's 11, then the whole thing has to be 22. That's all the segment addition postulate states, okay? So in this one, they gave us DS was 2x minus 8, and this portion of it was 3x minus 12. And then they told us right here that DT, so the whole thing, is 60. So we know if we added this part and this part together, it has to equal 60. And so then that's how you have to set up your equation. Part plus part equals the whole thing. All right. And here all you're doing is you're combining like terms. 2x and 3x is 5x. Negative 8 and negative 12 is negative 20. So we have 5x minus 20 equals 60. Add the 20 to both sides. We're going to have 5x equals 80. Divide both sides by 5. We get x is 16. Now, they probably wanted more information than just x is 16. So you probably will have to plug in 16 to x here. 2 times 16 is 32. 32 minus 8. We're going to get 24 for ds. Then we're going to check it with st. Are they supposed to be the same thing? Not in this case, because we don't know that these are not marked congruent or anything. We just know that this was a part and this was a part, and we knew the whole thing. So 3 times 16 minus 12, we get 36. Those are not the same. That's okay. We just want to make sure that 24 and 36, the whole thing, when you add those together, gets you to 60, because that's the part that we knew. So that's it for today. If you have any questions, please contact me. I hope you all have a wonderful day.